May 16, 2025. A warm front had positioned itself just north of downtown St. Louis, Missouri. Throughout the city, the air quickly became thick, humid, and highly unstable. At around this time, a man referred to as Blue Moon was driving through North St. Louis when the tornado siren suddenly blared from his phone. Just miles west of his current location, a massive, rain-wrapped tornado was racing his direction at nearly 55 miles per hour. As he frantically weaved through the crowded and narrow streets of North St. Louis, the tornado only continued to grow closer and closer. In an instant, the rain-wrapped, nearly mile-wide tornado engulfed his vehicle and threw it into the air. Moon's car was rolled numerous times, with nearly all the car's windows being shattered and the roof being caved in. After what felt like an eternity, his car finally came to rest. He was upside down, and his car was totaled, but he was miraculously still alive. In just under 30 minutes, the significant tornado caused a staggering $1.6 billion in damages, killed 5, injured 38 others, and left a mile-wide swath of destruction throughout the heart of one of the Midwest's largest cities. Days before the 16th, forecasters took note of a possibly widespread severe weather day incoming. The first note of the potential severe weather on the 16th by the SPC was the Day 5 outlook issued on May 12th, which indicated a 15% risk throughout parts of the central U.S. For the next 3 days, the slight/15% risk was maintained. Then, on the Day 2 outlook, an enhanced risk for severe weather was introduced, with the first note of significant tornadoes. At this point, the storm mode was still uncertain, which led to more conservative forecasts being issued. Storm mode is extremely important in severe weather forecasting due to the different impacts that different storm types can have. For example, a more linear mode usually causes more widespread wind events with less hail and strong tornado potential, while a more isolated threat can cause more significant hail and tornado threat. However, by the next outlook, it became more evident that the storm mode would be isolated, and thus more conducive for significant tornadoes, and a moderate risk was issued. As the 16th neared even closer, it became even more evident that the meteorological setup was nearly a perfect recipe for a widespread tornado outbreak across the Ohio Valley. A powerful upper-level shortwave moved across the upper Midwest, causing height falls and strengthening winds aloft to 70 to 80 knots by evening. These height falls, in conjunction with the cold front, allowed for ample forcing and lift to initiate storms. To put it simply, lift triggers upward air motion and sparks storm development. So, the potent upper-level shortwave combined with the surface cold front provided the necessary lift to initiate explosive thunderstorms across the region. This powerful shortwave and the strengthening winds aloft allowed for ample wind shear to sustain storms. Shear is the change in wind speed and direction with height, which organizes thunderstorms into rotating supercells. Deep layer shear reached nearly 65 to 70 knots, with storm relative helicity values over 400, creating a textbook environment for significant tornado formation. The exit region of a nearly 125-knot jet stream further enhanced the environment for severe storms. At the surface, a low-pressure system with a trailing cold front clashed with warm, moist air from the Gulf, with dew points in the 70s fueling instability. This warm, moist air acts as fuel for thunderstorms. These dew points in the lower to mid-70s, drawn from the Gulf, provided ample moisture, enhancing atmospheric instability. The significant tornado parameter, or STP, peaked at 9, and mid-level lapse rates exceeded 8 degrees Celsius. Lapse rates are important to severe weather potential because the steeper the lapse rates, the more unstable the atmosphere can become. In addition, CAPE values surged to 3,000 to 4,000 joules per kilogram due to extensive clearing and steep lapse rates. CAPE, or convective available potential energy, is the measurement of instability in the atmosphere that is needed to produce potent severe thunderstorms. The Storm Prediction Center then issued a moderate risk for severe weather on May 15th, highlighting a 15% chance of significant tornadoes, EF2 or greater, and a 45% chance of very large hail and damaging winds. As the 16th neared closer, the models continued to show a devastating potential. May 16th began with warm, humid conditions across the entire Ohio Valley. Temperatures reached the mid-80s and dew points hovered in the lower to mid-70s, creating a muggy and extremely unstable air mass. It was evident by late morning that the environment was setting up for disaster. Soundings taken from the National Weather Service offices around the region showcased classic tornado outbreak environmental soundings similar to other major outbreaks that occurred in the region in the past. These soundings suggested that numerous fast-moving supercells would erupt across the region in the early afternoon and potentially produce numerous strong to violent tornadoes. At the next update, the SPC maintained the moderate risk outlook and confirmed the potential for a widespread severe weather outbreak. By early afternoon, storms fired in southern Missouri and Illinois, organizing into supercells as they moved eastward. As for the St. Louis area specifically, forecasters at the local National Weather Service office were monitoring the potential for severe weather across the region early in the morning. An area forecast discussion was issued shortly before 3 a.m., discussing that the models had been showing that the greatest risk of severe weather across the region would exist between 1 and 5 p.m. However, at this time, the National Weather Service noted that the specifics of when and where the storms would develop were unclear. Shortly before noon, the Storm Prediction Center issued a mesoscale discussion concerning the development of storms over southwestern Missouri and eastern Arkansas. These storms had formed rapidly ahead of the cold front and were expected to develop into supercells over time. The SPC noted that the storm coverage would expand over the rest of Missouri as well as parts of Arkansas and Illinois as the day progressed. As mentioned earlier in this video, the now anticipated supercellular mode greatly increased the tornado potential and thus led to greater urgency in the National Weather Service's and SPC's forecasting. As a result, a tornado watch was issued across much of Missouri, including St. Louis, with the mention of potential for multiple intense tornadoes throughout the region. By 2:08 p.m., the warm front had reached St. Louis, and supercells began to develop ahead of the cold front and dry line west of the metro. At this time, southerly winds rapidly brought dew points in St. Louis up to nearly 70 degrees. The environment across and ahead of the approaching line of supercells was conducive for the threat of large hail potentially above 4 inches in diameter and significant tornadoes. Forecasters noted that the best conditions for significant tornadoes were not particularly expected to be as far north as the St. Louis metro. Instead, they were expected to be further south over southeastern Missouri and neighboring parts of Illinois and Kentucky. However, as an isolated supercell began to near the North St. Louis metro, it was only producing hail until something unexpected happened. At around 1 p.m., an isolated supercell fired just southeast of Jefferson City, Missouri. By 1:25 p.m., the supercell had become warned for severe hail over 1 inch in diameter and winds up to 60 miles per hour. The supercell continued to rapidly intensify further as it tracked eastward at nearly 60 miles per hour. As the isolated supercell rapidly approached the northern portion of St. Louis, it mainly produced large hail up to 2.5 inches in diameter and significant wind gusts up to 60 miles per hour. However, as the supercell crossed I-270 at 2:34 p.m., a tornado warning was issued for the entirety of North St. Louis. This tornado warning was prompted by the rapid and unusual tornado genesis of the storm. The rapid tornado genesis of the supercell was likely caused by a nudger that created an extremely strong RFD surge. A nudger is a supercellular interaction that occurs when a parent supercell is nudged from behind the RFD. Nudgers commonly lead to increased tornado potential. Additionally, the RFD, or rear flank downdraft, is a region of dry air wrapping around the back of a mesocyclone in a supercell thunderstorm. This area of descending air is thought to be essential in the production of supercellular tornadoes. While some supercellular interactions can lead to the demise of a supercell, this one did not. Within minutes, this storm went from a significant hail producer to a significant tornado producer directly over one of the largest cities in the Midwest, putting millions of people's lives at risk. Just minutes after the successful nudger took place, the storm began producing a significant tornado. At approximately 2:39 p.m., the tornado touched down in Clayton, just east of I-170 in St. Louis County, Missouri. Right after the tornado touchdown, it immediately reached EF2 intensity as it moved eastward through Clayton, damaging apartment buildings, homes, and low-rise buildings, uprooting trees and snapping tree branches. It then turned east-northeast, causing widespread EF1 damage to trees, power poles, and residences at Fontbonne University. Here, one area of EF2 level damage was noted in electrical wires that were snapped. The tornado then continued eastward and entered the city of St. Louis. As it entered St. Louis, Metrolink, St. Louis's rail transportation network, suffered damage to overhead power systems between Forest Park, Belvedere Station, and Brentwood I-64 station. The tornado then snapped more trees at the Wydown-Sinker neighborhood before causing additional widespread tree damage as it clipped Forest Park and the Sinker-Belvedere neighborhood. The tornado once again reached EF2 intensity as it struck Belvedere Place. Here, it heavily damaged multiple apartment buildings, damaged homes, shattered windows, and snapped and uprooted numerous trees. As the tornado moved through Central, West End, and Academy neighborhoods, more homes, churches, mid-rise buildings, traffic lights, power poles, and trees were heavily damaged. The strengthening tornado then impacted the neighborhoods of Fountain Park, Lewis Place, and Kingsway East. Here, several businesses and brick townhouses had walls and windows blown out and roofs partially and completely removed, and there were widespread damage to trees, power poles, and traffic lights. At around this point, part of the Centennial Christian Church with 3 people inside collapsed. Although everyone was rescued from the damaged building, one person later unfortunately died from their injuries. Other churches nearby had windows shattered and exterior damage as well. As the tornado continued now due northeast, 2 areas of low-end EF3 damage occurred on the northwest side of the tornado's path, with a strip mall being partially destroyed. Here, a brick townhouse was also flattened at EF3 intensity, and multiple other homes were largely impacted by EF2 level damage. By this time, the tornado had grown to a large wedge that was nearly a mile wide. The tornado then struck the Ville and Greaterville neighborhoods at EF2 intensity. Many brick townhouses and other homes were collapsed or heavily damaged here, with roofs removed and exterior walls knocked down. The tornado peaked around this area at mid-range EF3 intensity along North Newstead Avenue and flattened multiple brick townhouses nearby. Another brick townhouse on Marcus Avenue was also flattened at EF3 intensity, and a church nearby had its roof partially removed and its steeple knocked off. Around this time, the tornado warning for the area was upgraded to PDS due to a debris ball on radar confirming the presence of debris being lofted by the tornado. PDS, or particularly dangerous situation tornado warnings, are uncommon variations of the tornado warnings reserved specifically for situations of significant or violent tornadoes that have been observed. One method for confirming significant tornadoes without spotter confirmation using only radar cues is by identifying a debris ball, or TDS. A TDS, or tornadic debris signature, is an area of high reflectivity on weather radar caused by debris lofting into the air. These areas usually indicate that a tornado is at or above EF3 level intensity, and thus commonly prompts PDS tornado warnings. Along Natural Bridge Avenue, a tall transmission tower was heavily damaged before the tornado moved into the O'Fallon neighborhood just west of Fairground Park at EF2 intensity. Here, numerous more brick townhouses, other homes, businesses, and churches were heavily damaged, including some brick townhouses that had completely collapsed at O'Fallon Park. In the O'Fallon neighborhood, numerous homes were damaged at EF1 and 2 strengths, with some homes having their roofs completely destroyed. The tornado then continued northeast and crossed I-70 into the North Riverfront neighborhood. Here, the tornado damaged multiple warehouses and snapped power poles as it moved through the industrial area in a train yard along BNSF Railway's Hannibal subdivision before crossing the Mississippi River into Madison County, Illinois. The now smaller and much weaker tornado moved ashore west of Granite City, damaging trees as it moved east-northeast. The tornado then crossed Illinois 3 and struck the northern part of the city, damaging homes and snapping and uprooting more trees at up to EF1 strength. The tornado then crossed Illinois 203, damaging more trees, businesses, homes, and a medical center, causing minimal damage. The now much weaker tornado then struck Pontoon Beach, damaging more trees and homes. The tornado then moved to the northwestern part of Glen Carbon, damaging a storage facility and more trees. The tornado then crossed Illinois 157 and finally dissipated just southwest of Edwardsville and just east of the Southern Illinois University's Edwardsville campus at approximately 3:05 p.m. In all, the tornado damaged 5,000 structures and caused an estimated $1.6 billion in property damage over its 26-minute life, making it the 10th most expensive tornado disaster in recorded history when adjusted for inflation. The St. Louis EF3 was one of many significant and violent tornadoes that occurred on May 16th. Throughout parts of the Ohio Valley, 27 people were unfortunately killed directly from the impacts of mainly the London, Kentucky and St. Louis, Missouri tornadoes. The St. Louis tornado was not the strongest tornado of the outbreak, with peak winds being estimated EF3 152, but it may have been one of the most widespread. Satellite imagery taken in the days after the tornado showcased the extreme extent of the damage. Immediately following the tornado, 80 volunteer structural engineers affiliated with the Missouri Structural Assessment and Visual Evaluation Coalition converged in St. Louis the first week to assess the habitability of homes across the city, placing stickers on structures based on their integrity. Structures marked with red stickers were unsafe to occupy, while those with yellow stickers should be entered with caution. These stickers were helped to identify areas where people should attempt to avoid, and were non-binding and just meant for informational purposes. Unfortunately, in the tornado, 5 people were killed, with 3 being inside their homes, 1 in a vehicle, and the other at the Centennial Christian Church in Fountain Park. Additionally, at the time of recording this video, it is reported that another 38 people were injured by the direct impacts of this tornado throughout North St. Louis. Unfortunately, one thing that may have led to some of the people being unaware of the tornado was a failure to set off the sirens in North St. Louis. The failure to set off the sirens had been attributed by emergency management and city officials to a lack of an organization, as the county's emergency management commissioner was off attending an off-site workshop and the other emergency staff were unable to activate the sirens themselves. St. Louis Fire Department officials later stated that in a call, the emergency manager gave ambiguous orders, and therefore they did not sound the 60 outdoor tornado sirens placed around the city. However, fire officials later revealed that even if they had received clear orders, they could not have sounded the sirens because the emergency button in the office was not working. Sarah Russell, the city's emergency management commissioner, was placed on administrative leave following this incident. However, in response to the situation, it was reported that the city emergency management had been continually requesting more funding, as they had been receiving only 0.2% of the city's yearly resources, 7 times less than the comparable cities such as Kansas City and Chicago. Additionally, the rapid intensification of the supercell that caused the tornado due to the previously mentioned nudger only added to the confusion and unpreparedness of the North St. Louis population. The Federal Emergency Management Agency, or FEMA, dispatched 2 teams to North St. Louis immediately following the tornado, with their main focus set on the communities of Greaterville and Kingsway East. On May 21st, Missouri Governor Mike Kehoe announced that he would be asking President Trump for federal disaster aid following the tornado. On June 10th, it was finally announced that FEMA aid was finally available for the residents of St. Louis, nearly a month after the tornado. Governor Kehoe stated that FEMA had called the amount of residential destruction in St. Louis the largest the organization had surveyed since the Joplin tornado in 2011. As recovery efforts continue to happen throughout St. Louis, thousands of people still remain without homes and businesses, even a month after the tornado. Although the tornado was only rated EF3, it remains one of the costliest and one of, if not the, most impactful tornadoes of 2025. This video is dedicated to everyone who was impacted by this tornado and the other violent and significant tornadoes that occurred on May 16, 2025. As always, thank you guys so much for watching. I really enjoy making these videos, and they really take a long time to plan, script, voiceover, edit, and all the other stuff that's needed to make a video. So I'd really appreciate it if you like and subscribe. That helps supports the channel and really helps me out here, and I really appreciate it. Also, additionally, if you'd like to support the channel further, you can become a channel member today, and you'll receive a lot of behind-the-scenes benefits and different things. Before these videos come out, you can see a lot of different things about them. I usually post the next video that's coming out right when I get done with this one. So if you'd like to become a part of that, it starts as low as $1 per month. So I really appreciate that. That helps me out, helps me continue my mission of helping people be informed about these tornadoes and other events that happen. And also one final thing, if you're interested in learning about another tornado that happened in this outbreak, the London, Kentucky EF4, I already have another video on it. So I put the video at the end of this link thing. You'll see it's one of the 2 suggested videos here. I may also be doing the Marion EF4 at some point too, later this summer. So be tuned for that one. Stay tuned for that one. We'll see. I haven't decided yet for sure, but it might be on my radar. But yeah, in the end here, I thank you all for watching this video and supporting my channel. I'll see you guys in the next one next week, or 2 weeks from now. Sorry. Every 2 weeks I make these videos, so if you'd like to be a part of that and watch all these, don't forget to like, subscribe, hit the bell, all that. But I'll see you guys in the next one. Goodbye.
We got the strong tornado right here. Very large tornado directly in front of us.